is the second session about future programming languages and tools. And our first speaker is Agustin, all the way from Argentina. And he's going to be talking about substitution and categorization in a very playful way. Thank you.
Thank you for the introduction. Hello, my name is Agustin Rafael Martinez. I am from the University of Buenos Aires. I am a PhD student. And today I am going to present a general purpose programming language. In particular, I will focus on the minimal visual version of this language. In this version, it has 4 predefined symbols. And the rest of the symbols are defined by the user, are drawings. And the intention is to allow children to program with their own drawings. To begin, I am going to show some video captures to give you an intuition of what this language is about. And then I will make a little live demo. This is the minimal visual version of the programming environment. By means of a simple tool, it is possible to draw symbols, drag and drop them, and define simple programs. Concrete domains of the physical world can be represented, such as the germination of a seed, all based in 2 fundamental relations between symbols, substitution and categorization. Here in my hand, I have magnetic blocks. They belong to my son. And he plays with them since he was 3 years old. Today, he's 10, and he continued to play with these blocks. What I like about them is that they fit together by their smooth size. They don't have the usual sockets of other building blocks. They are so simple and so flexible that very young children can build with them. For me, to program is to build theories, as Peter Naur said. For me, a program is a construct of interlocking concepts, as proposed by Fred Brooks. And I agree with all Lehman Metzen that yesterday defended the point of view of programming as modeling. The name of the project is Representar, which in Spanish means to represent. This highlights the vision of the project. To program is to create epistemic representations of knowledge. I set out to build programs with the flexibility with which we put together these magnetic blocks, one next to the other. As a poet selecting his word to put together new verses. It is, as you can see, drawings can be made to represent also abstract domains such as chemical reactions or addition of natural numbers. It is a very common belief that programming helps in mathematical thinking and logical thinking. Currently, there is a lot of controversy in educational research on this, but if we can offer a way of programming that allows defining numbers and booleans, there will be no doubt about the contribution to logical thinking and mathematical thinking. An abstract domain that can be fully represented with drawings are booleans, and their fundamental operations and/or are not. And I would like to show you this example of the booleans. So here I have some drawings already made, true, false, and or not, and a drawing that will represent the abstract notion of Boolean. I will start defining the AND operation. True and a Boolean takes the value of that Boolean. False and a Boolean is always false. True or a Boolean it's always true, and false or a Boolean reduces to that Boolean. I also have to express that not true is false, and not false is true. And to end this model, I have to express that this drawing is an abstract notion of Boolean, and for that, I will define that true is categorized by Boolean and also false. So, as you may already guess, right here at the bottom, on the left, I have some expressions, and on the right, I can see the result of evaluating them. Usually, a programming console is for writing text. Consoles are for text. But here, I am proposing a different kind of console, a console for drawings. On the left, there are the drawings, the expressions, and on the right, the result. It's a readable apply loop console that updates live with liveness. So I think this is a contribution to visual languages for children. I would like to use this model of Booleans to represent a typical notation of procedural languages, which is the if-then-else notation. So here I have some drawings already made. And to define the if-then-else notation, I need to define two substitutions, one for each condition of the if. If the condition is true, then we have a phrase, a red phrase, else a blue phrase. In this case, I want that the phrase associated with the then be evaluated. So I define it this way. Unlike when the condition is false, then we have a red phrase, else we have a blue phrase. The phrase that should be evaluated is the blue one. But I have to do something else. I have to use a new symbol, a new predefined symbol to make these balloons, these blue and red balloon, general categories, phrases. They are just drawings at the beginning. The choker, the wildcard, it's a predefined category that categorizes every sequence of symbols. If I put the choker under another symbol, I make that symbol as general as the choker. So in this way, the blue balloon and red balloon became general categories. As we can see in the readable apply loop console, in the first line, the condition is false, and then the addition of 2 plus 2 was made. An important thing in the if-then-else is that one of the phrases, one of the expressions should be evaluated and the other should not. But here we can see that one addition was made, but how do we know that the other was not? Usually debugging or inspecting the execution is considered complex for children. But here, with one click, I can have a visualization of the execution. So in the first line is the initial expression, and I know that the first thing evaluated was the condition of the if. Then, when that condition was reduced to a truth value, then the if-then-else substitution could be applied. It was replaced by the addition, and the addition was made. So now we know that our notation created worked all right. Since I conceive programming as representing and not controlling, nor controlling a computer, nor controlling a cartoon character, I wanted the minimal visual version of this language to be just about manipulating symbols, evaluating symbols, seeing resulting symbols, there is no need to go beyond symbols to program with drawings. There are other environments in this project that allows to control. There is a more complex environment that allows to control a robot. With it is possible to define typical behaviors in educational robotics, such as going to the light and avoiding obstacles, and combine those behaviors in more complex behaviors. I have shown how to define categories, such as Boolean. So the language does not need to provide predefined types, but rather allows them to be created. There is no need to provide notation since the language allows to define notation as if then else. It is possible to parameterize code. The additions 1 plus 1, 2 plus 2, they were the parameters of the if then else. They were the blue and red balloons. Defining notation, defining categories, parameterizing code, these three features are not usual in conventional languages. And they are certainly unusual in visual languages for children. And when they appear at a big cost, the cost of complexity. But here, one drawing next to the other, ordered sequentially, separated in different lines, only that to have these three features. I have shown the visual environments. There is also a textual version of the language. With this version, I have been able to define natural numbers completely, fractions, and all based in the two fundamental relations between symbols. The fact of having a textual version of the same visual language allows us to deepen any domain where programming with drawings is limiting. So this opens a new alternative in programming education. Instead of changing the language in the learning process from simple programs defined visually to complex programs defined with another language based on text, I propose to change the tools and continue to program with the same language. It is considered the gap between visual to textual languages is considered a barrier in the learning process. For me, there are two forms of abstraction in programming languages that tend to appear as a duality. Functions and data types in functional languages, messages and classes and prototypes in object-oriented languages. I think that the power of expression and simplicity of this project lies in having addressed the essence of this duality in two fundamental relations between symbols. In the minimal form, these relations are represented in two visual combinators that can be freely dragged and dropped. Here we can see two children in an informal context. They are representing color combinations. They are using the debugging tool. They are inspecting the execution. They are using both relations, substitution and categorization. And they are also making PR programming. They are changing the one that controls. This is spontaneous. I believe if I continue to go deeper on this path, I will be able to reach that image that inspired me from the beginning, that was to be able to program with these magnetic blocks with my own hands. Here, I will show you a photo montage. This is an idea of what programming with drawings could look as a tangible user interface for children of the future. Drawings with crayons on paper, on the floor, and then using those drawings to program. The protagonist of this picture is Dionisio. my son, my 10-year-old son, that I told you about at the beginning of this talk. I hope you enjoyed the presentation. I tried to make it fluid and dynamic as my language. I encourage you to take a look at the paper if you are interested. There are many details in the text that I have just mentioned here. And I open to questions, ideas, suggestions right now during the rest of the conference and also by email. Thank you very much.
Still not working. Oh dear, sorry.
No problem with that. I'm Italian.
Good, go for it.
So, in the text representation, we see that you have parentheses. But in the graphical representation, the if managed to understand that 1 plus 1 was, parenthesized as a sub-tree of the if expression. How does that work?
Well, I make it simple. The answer. The language tries to evaluate the sentence as a whole. If there is no substitution, they will try to reduce it by parts. In this case, the language finds a part, an expression, it reduces that expression to a truth value, and then can again try to substitute the whole. That's the way, synthetically.
You're closer. Thank you.
Is it working? Oh yes. Yeah. Thank you for your presentation. I have a related work question, which that I'm familiar with some other systems like Lego Mindstorms or the video game Baba Is You that have similar systems of block manipulation for things that are like programming or logical languages. And I was wondering either if those were a source of inspiration for you, or if you have, or if you had some goal in mind of differentiating your work from those systems, and you think there's something this does that those other systems don't do as well.
Well, I don't know. I know Lego Mindstorms. I'm certainly that you cannot define booleans and numbers and categories with that. You cannot do it also with the Scratch and so. But what inspired me really, this project started as a textual language. It didn't start as a visual language. The process of creating took me to simplify tools and to arrive to this minimal visual version I presented at the beginning. For instance, the robotic version was the first visual version, very more complex. And then I tried to simplify. Trying to answer your question, we can continue. So with coffee, I think there are the things I mentioned, defining categories, defining notation, and parameterizing code. These particular elements that belongs to this language are not present in other visual tools for children.
Thank you.
Thank you. I'm going to run over here. Sorry. There you go. Thank you. Try to maximize time.
Thanks. I was just wondering if there's any form of, first of all, I want to say that this is amazing. And next I'll ask, is there any form of type checking, or what would happen if you write if to then? What would the user see?
This is a dynamic language and at a level higher than previous languages that are dynamic. So there is no type check at all.
Mm-hmm.
Every expression is valid and can be executed. If someone writes an expression and does not respect previous notations that were expected to be used, it will be evaluated. If there is no substitution to reduce it, then the answer will be the same expression that was evaluated at the beginning. So,
And a continuation, what would happen if there were two different possible executions?
there could be more than one substitution that could be applied to expression. And in this case, well, there is a criteria. I tried to simplify the question of him. That was regarding also on that. He tries to evaluate the whole, but maybe when the whole could be more than one substitution to replace it. In this case, there are a priority that can be regarding how many exact terms is the original phrase with the expression, with the substitution, and in that way, the substitution is chosen. This is explained in the paper, of course.
Yes. Thank you very much for showing this. So those icons looks like sort of done semi-professionally. Those are not done by children. And from my experience with working with children to do this kind of stuff, if there's a painting to some children tend to sort of cannot escape from the drawing part, but not the programming part. And there must be some balance you have to strike when you do it with
You
actual
cannot
children.
escape. You cannot escape.
I mean, no, the children. It's
Children
there's
cannot
for
either.
children.
You can
There's
try
a
to draw outside, but
there's a children needs some children need some nudging to move on to sort of the what we think more interesting part, which is combining those. But sometimes children can keep drawing forever, and so there must be some balance. So I'd like to hear your experience
I
with
believe
it.
that the examples of Booleans, natural numbers, they are complex examples that can be made by children in an educational context, guided by a teacher, not by themselves. Of course, they can do by themselves simple things as the one I show on the video, thinking about how they combine colors. They know very well that domain, so they can represent it. But when the domain is complex, in the case of numbers, I am representing the addition basing on the basis of the previous and next relation between numbers. That has to do with piano actions, so it is a little complex. It is very simplified, and it takes some drawings. They don't need to know piano and the actions, but there is a complexity and should be addressed in a context.
Yeah, thank you for a very cool and interesting presentation. I was wondering about associativity in this. So, for instance, if you want to introduce minus as an operator, you would want some you would want it to start evaluating one of these before the other. If you have 1, minus 2, minus 3, or something like that. Do you have any thoughts on that, or is this possible to do currently?
I guess I understand the question, but I'm not sure. When there is an expression, an algebraic expression, usually languages use an order to evaluate them. And the order has to do with the language syntax. For instance, I'm using here Smalltalk, and it has an order of evaluation. And if you want to change that order, you have to add parentheses. Here, in the textual version, but also in the visual, you can create substitution relations that express that for a certain pattern, the operation that should be evaluated first is, let's say, multiplication, and then addition or subtraction. So this is being made on the textual version. On the textual version, the syntax is extends a little bit. I didn't went onto that.
First of all, thanks. That was really fascinating to watch. So I had one more high-level question that I think you already sort of answered, which was, did you choose sort of the examples that you showed to us here? I guess you chose the more sort of to resonate with this audience and not necessarily as examples of something that you would give a child, at least at the first step. Like as you were saying, like for example, with like the natural numbers and something like that's probably at least not something that a child would be able to figure out by themselves, sort of with trial and error to reach that point where they can represent that.
I don't believe that we have to make tools for them to learn by themselves. We can give them tools to play, to feel good, but some things need a person, an empathic person with them to guide them. But you ask another thing also.
So, okay, so my other question, which is
About
probably
examples, where do they come from?
My question was kind of what you showed us here is something that I guess everyone in this room is like familiar enough with, that they saw what was going on here, and like this was a nice example for that. But I guess for children, like for example, what you showed with the colors seems more like something that would be interesting for a child than reconstructing
examples
addition.
are chosen for you as an audience.
Yeah.
In particular, the if then else notation, and it's a good example to show the possibility of parameterizing code. But to a child, they don't need if then else to use this language. They don't need this procedural notation. As in object-oriented programming, it is not recommended to use if. You can replace it with polymorphism. In this case, you can replace it with substitutions. So it was an example, and what I show, it was focused on you to understand the project. And it's not a curricula for children. This is a prototype on a laboratory. It has been tried out by children in my house. One of them was my son, and the other was a friend that came to sleep, and I was working with the computer, and they picked the computer, they take it out of my hands, and they started to play. It was spontaneous, and I filmed it, and then asked the mother of the kid, "Can I use the video to promote my project in the conference?" "Yes," she said. So the video is now project.
Awesome. I had like one more. Maybe we can. Okay, we might also be able to ask it offline. But like, even in these simple examples, I was wondering, how do you sort of handle when you have binding, in a sense, like when you have I think you had it in your if-else example where you have these two placeholders like red and blue, and then it becomes like either red or blue. What happens if the same one appears twice on the left? Like, how do you pick? Is it the first one, or is it just sort of arbitrary? Like, I guess you don't have any notion of binding here.
It takes to another thing that it is on the paper.
Okay.
On the left side, there is a type, and on the right side, the same symbol is representing a parameter.
Okay.
So it's intuitive, it's simplified, but has some complexity. In the textual version, you can define also parameters. And in the paper, I explained that I proposed, instead of type inference, parameter inference, I call it. So it's what is happening right here. Thank you very much for your question. Thank you all.
Let's thank the speaker again. Good, thank you, Agustin.